Okay, this is part 284C3M1b7c8e13c9c6d3p38d19d7b9h2. Line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7b9h2. QCD Lattice Temp Alloy Mix Formula 5G Wow Seti. Well, there's the alien radio signal, and this is a continuation of the last video. I just did this in like 5-10 minutes, and it basically was a formula idea that I came up with. It's a formula for gold ions, QCD quarks, and lattice, raising the temperature to get a better reading idea from the Wow data, line 22. Okay, April 21st, 2013. While filming this video, I came up with an idea. So this is the previous video's title, Quarks Break Free Fermion Split. And there's the line of data there. So then it was about how to split a fermion 2 for the previous of van der Waals force molecular. And the keyword was split intramolecular attractions. So, what my thoughts were in part 2 is how to split a fermion 2 video. The keyword ideas from the QCD Lattice PDF results from LHC ALICE, creating a formula for you to try. So I'm going to Google some keyword ideas. Superalloy spike to measure quarks with gold ions, liquid water and steam, using a steam mixture with an alloy to spike the temperature of the quark you are trying to measure to see what happens. And then, so I Googled the search keyword idea of superalloys raises temperature of water. And then I took a little break, and two words came into my mind. It said mix your copper ions with titanium. So then I'm going to Google to see what happens with that. So, getting copper from chalcoprite, C-U-F-E-S to the power, not the power, S with a little tiny 2. Chalcoprite, also known as copper pyrites, and similar sulfide ores are the commonest ores of copper. The ores typically contain too low percentages of copper and have to be concentrated by, for example, froth flotation before refining. And that's from www.chemguide.co.uk. So getting copper from chalcoprite, C-U-F-E-S with a little 2. Chalcoprite, also known as copper pyrites, and similar sulfide ores are the commonest. This is a quote from a blog, by the way. Commonest ores of copper. The ores typically contain low percentages of copper and have to be concentrated by, for example, froth flotation before refining. It says, note, you will find a brief description of froth flotation on the Introduction to Metal Extraction page. So he's got all sorts of stuff linked together, this blogger. The process, the concentrated ore is heated strongly with silicon dioxide, silica, and air or oxygen in a furnace or series of furnaces. The copper 2 ions in the chalcoprite are reduced to copper 1 sulfide, which is reduced further to copper metal in the final stage. The iron in the chalcoprite ends up converted into an iron 2 silicate slag, which is removed. Most of the sulfur in the chalcoprite turns into sulfur dioxide gas. This is used to make sulfuric acid via the contact process. An overall equation for this series of steps is blurry. I don't know if that helps there. I made it bigger and it just made it blurry. Sorry. The copper 1 sulfide produced is converted to copper with a final blast of air, and that's the other equation that he has on his thing. So his warning is, this is a simplified version of the process, an attempt to condense the whole thing down to 2 fairly straightforward equations. The problem is that there are all sorts of variations on this extraction. One of these does the whole thing in a single furnace, and the equations above probably best represent that particular process. This quick summary is probably unsuitable for anything other than a UK A-level purpose. If you are working at a higher level or want proper technical details of particular methods, you will need to look elsewhere. Good luck doing this. I found internet sources fairly unhelpful. Several chemistry sites gave a method which is hardly used nowadays. Other sites give technical details but no equations. I didn't find a good source of both. So that's what this blogger says. So the end product of this is called blister copper, a porous, brittle form of copper, about 98 to 99.5%. And this was from www.chemguide.co.uk. And so I came up with the keyword titanium aluminum nitride. The keyword source was from, I googled the word titanium, and this is what came up. So www.tooling, no, not tooling, it's toolingu.com. So quote from Wiki: titanium aluminum nitride, or TiN, or aluminum titanium nitride, Alton, for aluminum contents higher 50%, oh boy, stands for a group of metastable hard coatings and consisting of the metallic elements aluminum, titanium, and nitrogen. 4 important compositions. Metal content 100% are deposited in industrial scale by physical vapor deposition methods. So this is aluminum titanium nitride coated end mills using cathodic arc deposition technique. Keyword ideas: sulfuric acid raises temperature. Quote from a Google search: concentrated sulfuric acid in water. Of course, that got my attention, right? Sulfuric acid and water together. And sulfuric acid you get from copper. So www.siegen.de. There's the link there, and then there's the Google link there. Adding concentrated sulfuric acid to water causes an immediate temperature increase. Initial temperature, final temperature is 131.2 degrees Celsius. So the keyword ideas are: nano composite alloys generate high temperature. So I quote from some PDF results: nano composite phase change memory alloys are very high temperature data retention. So when I Googled these words together, this is what came up. Abstract, and I didn't break it down, sorry, all clumped together there. It's easier to read it when it's just in different little paragraphs, right? A little easier on the eyes. So phase change memory alloys based on germanium, sorry, it's not a flower, germanium, antimony, and tellurium with SiO2 nanophase dielectric inclusions are investigated for material and electrical properties. The new alloys are prepared by co-sputtering with a SiO2 target, creating nanophase dielectric inclusions. The addition of the dielectric inclusions significantly increases the crystallization temperature without affecting the required program current. In memory device configurations, the nanocomposite alloys exhibit a 10-year data retention above 200 degrees Celsius and a cycle life greater than 1 times 107 cycles, while maintaining the SET, or SET in capitals, programming speed of 250 ns. And it says NSPEC, controlled indexing, crystallization, dielectric materials, nanostructured materials, phase change memory, silicon compounds. Non-controlled indexing is SiO2, crystallization temperature, electrical properties, high temperature data retention, memory device configurations, nanocomposite phase change memory alloys, and nanophase dielectric inclusions. And then the author's keywords is data retention, GST, non-volatile memories, NVMs, and phase change memory, PCMs. And that went out July 2010 at IEEE Electron Devices Society. And there's the link there, ieexplore.ieee.org. So formula for measuring golden ions in quark gluon plasmas for QCD lattice experiment ideas. Formula from the data is liquid water, steam, mixture of superalloys, elevated high temperature, QCD lattice superalloys, spike, measure, quarks, gold ions, LHC ALICE, liquid water, steam, mixture, alloy, spike, temperature. Quark measurement results: superalloy raises temperature, water, mixture, copper ions, titanium, copper, chalcopyrite, CuFeS with a little 2, copper pyrite, sulfide ores, concentrated froth flotation, refining, metal extraction techniques, concentrated ore, heated strongly, silicon dioxide, silica, air, oxygen furnace, series of furnaces, copper 2 ions, chalcopyrite, reduced, copper 1 sulfide, reduced, copper metal, final stage. Iron chalcopyrite, convert, iron 2 silicate slag, remove, sulfur chalcopyrite, sulfur dioxide gas, make sulfuric acid, contact process, overall equation. That's his equations. Copper 1 sulfide produce converted copper final blast air. Again, that's his equation again. Another one that he came up with the blogger I'm talking about. Simplified condensed 2 equations variations extraction single furnace. Particular process UKA. Level purposes working higher level proper technical details methods blister copper porous brittle copper. Mixed with titanium aluminum nitride, aluminum titanium nitride, aluminum content stands, group metastable hard coatings consist metallic elements, aluminum titanium nitrogen, 4 important compositions, I forgot the I, metal content deposited industrial scale physical vapor deposition methods. Aluminum titanium nitride coated end meals cathodic arc deposition techniques. Sulfuric acid raised temperature add concentrated sulfuric acid. Water temperature increase 131.2 degrees Celsius. Nanocomposite alloys generate high temperature. Formula keywords from PDF file. Nanocomposite phase change memory alloys, very high temperature data retention. Phase change memory alloys, germanium, antimony, tellurium, SiO2, nanophase dielectric inclusions. Material, electrical properties, add electric field, Higgs boson, signal strength, collide, and LHC ALICE. I'm not sure if you can do that, but, you know, collide it wherever you got to collide it. New alloys, co-sputtering, SiO2, silicon dioxide plus your target. And this is what came up. SiO2, I googled it, I didn't know what it was. So it's a silicon dioxide sputter target. There's the width 3 inches, diameter by 0.250 thick. That's what you want to use. That's from the store dentonvacuum.com. And then you want to, the rest of the formula says create nanophase dielectric inclusions, increases crystallization temperature without affecting required programming, current memory device configurations, nanocomposite alloys, 10-year data retention, plus 200 degrees. I forgot to put a Celsius. I think it's Celsius. Cycle life greater than 1 times 107 cycles, maintaining set programming speed of 250 ns. I think they said 200 degrees Celsius. Let's just double check here. Yeah, it is Celsius. Sorry. I better change that, right? So that's going to go in with the notes with the video. And the keyword for the next video will be, let's see what we got here. And we're going to look at split supersymmetry. We're looking at how to split a fermion in 3. Okay? In the next video. So I just continued the series. And put that right here. Looks good. Got a yappy dog out there. This is why I start videotaping really early in the morning, because there's a lot of dogs around here and they just bark, 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 bark like crazy. Okay, thanks for watching.